All right, so today what we're going to do is we're going to begin our look at triangles. And I know that you've studied triangles in the past. It's in the curriculum for year 7 and year 8, but we're going to just take it a step further this time. Specifically, when we talk about triangles, we're going to be talking about angles and some measures of angles, since we've been talking about that a lot lately. The first thing we want to remind you is that a triangle is simply a polygon. And remember, a polygon means a closed shape of straight lines with 3 sides. So it's a very special type of polygon. It has exactly 3 sides. And what we're going to do today is we're going to learn a little bit about classifying triangles by their sides, classifying triangles by their angles, and then learning a little bit about the measures of angles. Okay? Right, so what we're going to do is we're going to go to the book and we're going to look at some of these definitions. Again, one of the bad things, or the worst things about the study of trigonometry, or the study of geometry, and measurement is that there are so many definitions and you have to memorize all of them. So keep that in mind as we move forward. So the first thing we're going to do is learn to classify a triangle by its sides. So I want you to write classification by sides. Now, ironically, a triangle has 3 sides, and there are 3 different classifications by sides. And you're going to see the same thing is true as classifying by angles. So here are the 3 classifications. The first one is called scalene, or a scalene triangle. Scalene means that there are no equal sides. The second type of triangle is something called isosceles, and I apologize for the Greek, but can be helped. Isosceles triangle means it has exactly 2 equal sides. So any 2 equal sides makes it isosceles. And the last one is something called equilateral. And what that means is that all 3 sides are equal. So equilateral triangles have 3 equal sides. So you need to make sure you remember that when you're classifying by sides, there are 3 different types of triangles that you're going to see. And we're going to work on several of these today. Okay? The second type of classification that we're going to look at today is we're going to look at classification by angles. Now, this is just another way of writing out or describing a triangle. So again, we're going to look at angles and the type of angles that we've looked at before. So the first one is what's called an acute angled triangle. And we know that it's acute angled triangle because all of the angles are acute, which means they're all smaller than 90 degrees. And you don't really need to measure these. Just kind of look at them, and you can see if they're smaller than 90 degrees, then they're definitely acute. The second type is another word we've used before. This is an obtuse angled triangle, and it has 1 obtuse angle. Now, it can't have more than 1 obtuse angle because that would make it, you can't make a triangle have more than 1. But if you look at this angle here, this one is really big. It's bigger than 90 degrees, right? If it was 90 degrees, it would be like that, right? So this one we can tell that it has an obtuse angle. And 1 obtuse angle is all you need to turn it into an obtuse angled triangle.
Stacy's going to give a report to us this week.
Then we have one more, and that's what's called a right-angled triangle. And you know that it's a right-angled triangle because it has 1 right angle. Oh. And again, remember that you are required to have something that tells you. It can give you the little box in the corner. They can say the measure is 90 degrees, or they have to say that it's a right-angled triangle. So you have to be very specific in order for it to be determined, classified as a right-angle triangle. So what we're going to do is just jump to the exercises and look at some of these classifications. Now, there's more properties of triangles that we're going to talk about, but I just want to talk about these for just a second before we jump into those. So, we want to first, here we are in exercise 9b, classify the following triangles as scalene, isosceles, or equilateral. Now remember, scalene, isosceles, or equilateral have to do with the measurements of the sides. So for example, this first one, notice that this side is 8, and that side is 8, and that side is 7. So it has 2 equal sides, and 2 equal sides means that it would be isosceles. Okay? Here we have 3 different measures, therefore that one would be scalene. Here we only have 1 measure, but remember those little lines on the sides mean that they're all the same, which would make that equilateral. Okay, so you're going to be classifying some of those. I wish they'd give you more so that you could do more. Here we go. They're good to give you some more. Good. All right, classify the following as acute, obtuse, or right. Well, the right-angled one is really easy. The only one with the right angle symbol is right there, so that's the right-angled one. Okay. 80, 40, and 60 are all 3 smaller than 90, therefore that's the acute angled one. And 95 is bigger than 90, therefore that one is the obtuse angled one. So really quite simple. Okay? Good. Now there are a few other angle properties that we want to talk about, and these we're actually going to be property of triangles that we're going to talk about, and these are going to require a little mathematics in some cases. Okay? So write down properties of triangles. And all triangles have the following properties. Okay, so let's look at the first property of a triangle. And that is the sum of the interior angles of a triangle is always 180 degrees. So if we took A and B and C and added them together, they will always equal 180 degrees. So it doesn't matter what the angles are, they will always add up to make 180, all the angles inside. Which means that if you know 2 of them, you could always find the other. So if you knew A and you knew B and you were looking for C, we could just make that an equation equal to 180 and solve it just like we did when we were looking for complementary and supplementary angles. Okay, so if you know some of them, then you can use the little math to find the last one with some algebra. Okay. Here's one that you'll see occasionally. Any exterior angle is equal to the sum of the interior opposite angles. Now write that down and then let's talk about what it means, because those are some strange words in there. All right, so let's look at what that looks like. So here, x, we don't know what x is. That's the angle we're looking for. But if you look at its location, it's on the outside of the triangle, right? And so that's why it's called an exterior angle. It's on the outside. Now, it could just as easily been on a line somewhere else. You could extend this line, and that's an exterior angle. That's an exterior angle. So there are 3 exterior angles as well. Well, and then you could be looking for this one, but their opposites are going to be the same. So anytime you have a case like that, then as long as you know the 2 angles on the inside that are on the opposite side from the exterior angle you're looking for, then you can simply add those together. Okay? So whatever those 2 interior angles are, if you add those together, you'll get the opposite exterior angle. And again, it doesn't matter which way the line went. If you were looking for this one, these are two angles, opposite angles, therefore they're equal. So that one would be equal to A plus B as well. So you can't forget what we've already done as we move forward. Okay, and we'll practice these so that you can get a little more practice. And the longest side, and this is just a fact about it, the longest side, so sorry, the longest side is always opposite the largest angle. So take a minute to write. So let's pop down to the exercises and see how some of these properties come into play. Okay. So these diagrams are not drawn to scale, but the information on them is correct. Find the values of the unknowns. So here, these are all interior angles, yes? So we know that they all should add up to make 180 degrees. So we're simply going to take the ones we know and add them together. So 20 plus 30 is 50. Plus c equals 180. And then we can subtract that 50 from both sides, which tells us that c is equal to 130 degrees. Okay? So if they all add up to make 180, add the ones together that you know, and then subtract that from 180 to find the one that you don't know. Look at this one. They give you 47, but that's the only number you have. But in reality, they give you another number as well, because that little square means that that one is 90 degrees, always. Okay. Drop down to the bottom here, and this is an exterior angle. And an exterior angle is always equal to these two added together. So that means that 167 minus the 36 I know tells me that x, the unknown one, has to be 131 degrees. So if you're missing one, you can just subtract it to find the others. Here, I'm looking for the external angle, so that means I'm just going to add that, and that will give me my E. Okay, so you're going to practice that mathematics a little bit with those angle properties. Okay, and here they're going to give you some statements using real life situation. Okay. Following triangles are not drawn to scale. State the longest side. Well, the biggest side angle is 118, so the longest side is side AC. That line AC. Okay. What else did they do to you? Okay. Just some more bigger ones. We're not going to get to those. We'll come back to those, but we'll do the rest of these. Okay, so we've talked about classifying triangles by their angles, classifying them by their sides, and then a few properties about triangles involving the measures of their angles. So what I want you to do, these begin, let's see what exercises these are. This is exercise 9B. And it's on page 174. That's where it starts. I want you to do numbers 1 through 6. I've already done a lot of them for you, but go back and redo them on your own just to make sure that you're really understanding what's going on.